ఈరోజు వచ్చేసి 6th యూనిట్ స్టార్ట్ చేసుకున్నాం. ఆసిలేషన్స్. So for every topic they will having some small introductory topic. So why should we learn? Why should we study about this oscillation topic? Means let me check one. So will you please in our daily life we can observe this type of motion. Let's assume I am taking the one of the simple pendulum type motion. So this is the simple pendulum which is moving from center to one side to other side. It is moving like this. This is the motion of the simple pendulum. So this is the main wheel of the wall clock. So the main wheel of the wall clock, it will move like this. To and fro motion, so it will go like this. If you observe this one of the object which is floating on the water surface, due to the oscillations, due to the waves of the water waves, the body will can move up and down like this. It can move. This is the motion. So if you take a loaded spring which is hanged from the rigid support, this is a loaded spring. If you pull with a small distance, it can move up and down. So will you please observe this one? So here the pendulum is oscillating from its moving position. Here is the main wheel of the it will make oscillating wheel. We will call it as oscillating wheel. So in the wall clock wheel also it is oscillating from to and fro motion. Here also will you please look on the object which is floating on the water surface. Due to the waves produced on the water surface, it is moving up and down. So if this one, a loaded spring which is pulled with a small amount of displacement in downwards, so if you release that one, it will make an oscillation from up and down like this. For every case we are observing these type of oscillations. So what is the kinematics? What are the parameters is there in the oscillations? How can you determine the position of the object? How can you determine the velocity of the object? We need to know what is the position of the object. That means where it is having, we need to know and so on. And also we need to know velocity of the object. That means how much velocity the body will having at a given time. So we need to know what is the acceleration of the object. So acceleration of the object at a given time. So this is the time. So and also we need to know energy of the object. Energy of the object. So the energy may be some of the potential energy, some of the kinetic energy of the object. So these type of physical quantities we need to know about the object. So that means while the body is oscillating, so as per the study of the object, we need to know these many physical quantities which can be determined with the help of the oscillation of the. If you study the oscillation of the topic, we can easily measure what the position, velocity, acceleration, and also energy, and also other some parameters which can be easily determined. Because of we are as in our daily life, these type of activities are involving. So the loaded spring also we are studying, the oscillation pendulum also we are studying, so the object also studying, so the wheel, the wall clock wheel, main wheel also we are studying. Like that these objects are involving in our daily life. Means we need to know the exact physical quantities of that object. So that means the goal of this oscillation topic means we are studying the physical quantity of the oscillating bodies. These are the only some physical quantities I written here. So there may be more number of physical quantities which will come in your topic. So the goal of this topic is to study the physical quantities of the oscillating bodies. So the oscillating body means it is having the So the oscillation, what is meant by oscillatory motion means it will having the two types of oscillatory motion. First we need to know the what is meant by periodic motion. So the motion of the object in the oscillatory motion, we need to know the main two types of motion. Let me write that one. The first type of motion is the periodic motion. Periodic motion. So to know the periodic motion means the general example which can be having means let me take this is the sun. So around the sun, the earth is revolving around the sun in the particular interval of time. In every year the earth will be completed of one revolution, because of, let me take it is the earth. It is the earth. Let me take this the sun. So for every year, for 1 year, the earth is revolving around the sun. So that means it is completing one revolution. That means will you please look on this one. Periodic motion means this body is repeating. The motion is repeating in equal interval of time. That means for every year, for 1 year, the body is completing. It is repeating its motion. So for let me take it is a year at a starting state. After 1 year, this will complete the same position. After next year, this will complete the position will be same place. Third year, fourth year, like this. So that means the motion of the particle which repeats itself along the same path. That means it is moving in the same path, and it is in equal interval of time. So it is in equal interval of time the motion is coming, and also it is repeating in the same path. That motion is named as a periodic motion. Let me write the definition of this periodic motion. The motion of the particle, which repeats itself along the same path in equal interval of time, equal intervals of time, so is called periodic motion. So is called periodic motion. So that means in the periodic motion the condition is the particle is repeating its motion in the same path. That is the first condition. In the periodic motion, particle is repeating. So it is repeating in the same path. That is the very, very important. Same path it is repeating, but it is repeating in equal interval of time. That means for every particular time, the particle will complete it will repeat its motion. So that is the periodic motion. Let me take some of the examples for the periodic motion we can easily understand. So the rotation of the earth around the sun. Take some examples. The rotation of earth around the sun. This is the very easy introduction. The vibration of the stretched string. So the vibrations of stretched string. So that means if we take the violin or guitar, so that means that is the stretched string. So this is the guitar, this is the wire which is having, it will look like a stretched string. If you vibrate this one means it will move like this, to and fro it will move. So in equal interval of time, this part of the vibration will be same. That means it is a periodic motion. If you go to the another one, so the rotation of the electron around the nucleus. The rotation of electron, let me take this electron, so around the nucleus. Now if you go to the another one, vibrations of the prons, of tuning fork. So tuning fork means it will look like U-shaped object like this one. So if you if you hammer with rubber hammer means the tuning fork will start with vibrate. So it will vibrate like this. It will vibrate. The hands of it will named as the prawns. The sides of these will named as the prawns. This is the handle. This is the handle of the tuning fork. If you vibrate these prawns means it will vibrate in the left and right like this. So these vibrations are named as the. This is also we will call it as the periodic motion. If you go to the another one means so if you go to the oscillations of the simple pendulum, as we discussed in the above one, oscillations of the simple pendulum. Oscillations of a simple pendulum. So if we go to another one means we already discussed in the oscillated of the loaded spring also. Oscillations of loaded spring. This is also the periodic motions are only. So the oscillations of the floated body on the water surface. Oscillations of floating body on water. So any if you take any one, these are the some of the examples in this one. What does it mean, sir? We in the periodic motion, what is the main property? The body is continuing, the body is repeating along the same path. That is the first condition, and also the body is repeating the motion in equal interval of time. So if you take the period of the time period of the Earth to complete the one revolution is 1 year. Like this, if you take the second pendulum. So second pendulum means you can easily this is the pendulum. So the second pendulum means it will to move from the mean position to the one side, and it will come to the mean position to the same mean position. It will take the 1 second. It is the second pendulum condition. So if you go to the other side means if you take the 1 more second. So to go to the other side and it will come to the same side means 1 more second it will take. The second pendulum time period is the 2 seconds. So in every 2 seconds the pendulum will complete. The pendulum will repeat its path. From this means from this stage it will move, and also it will go, it will come back, and also it will go to the other side. It will come back to the same position. The time period of the second pendulum is the 2 seconds. So like this, the vibration of the prawns of the tuning force, it will having the another time period. So like that it will having the. So the main concept is here, the motion of the particle which repeats itself along the same path in equal interval of time is named as the periodic motion of the object. So that is the periodic motion. So now let me go to the another one. So another one is the oscillatory motion or vibration motion. So another case of the main oscillatory motion or vibratory motion. So this is the important for us. As the oscillatory motion is the oscillatory motion and vibratory motion is the special case of the periodic motion. It is the special case of periodic motion. So it is the special case of periodic motion. So what are the main difference between the periodic motion and oscillatory motion means in the oscillatory motion the particle should move along the same path in this one, which one in the periodic motion. So that means in the oscillatory motion means the particle move along the same path in a straight line. That is the very important. Let me write one small correction here. One small correction. Yes. let me take the definition of this one. Oscillatory motion. So oscillatory motion means if the particle in periodic motion, the periodic motion moves to and fro. To and fro means it is moving front and back. So it is moving like the front and back. That is the main importance here. In the periodic motion, the particle can move in the same direction only. But in the oscillatory motion, it will move front and back. So that means back and forth. We will name it as the back and forth. So it will mean as the back and forth. Back and forth. So like that, the to and fro means and back and forth. It is named as back and forth along the same path. Same path. Then its motion is named as then that motion is named as oscillatory motion. What is the main difference in this oscillatory motion means? It is a periodic motion only, but the condition is the body should execute to and fro. To and fro means back and forth. That means from mean position. So the body should move from its mean position. Let me take, if the body started from here, it should go from forward direction is the fro. We will name it as in backward direction is the fro, and it should come back to the mean position and should go in backward direction is the back. So again it will go to the forward direction, but this motion should be executed along the same path itself. Let me take the pendulum. So it is the pendulum. So it will move like this direction, and again it will come back. So into the main position, and again it will go to the another direction, and again it will come back. So like this it is moving. That type of motion is named as the oscillatory motion. So what is the main condition here? So in the oscillatory motion, the particle should execute along the same path with the to and fro motion. That is the vibratory motion or periodic motion of the object. So will you please look on this one? All periodic motions are not a oscillatory motion. Let me check here. All periodic motions are not a oscillatory motion. So will you please look on this one? The rotation of the earth around the sun, it is not a to and fro motion. It is moving in circular path. It is not coming back. So that means it is not a oscillatory motion. The vibration of the string is the oscillatory motion only, because of from the mean position the spring is moving in upward direction, the spring is going to the downward direction. So if it look like a to and fro motion only, so it is going fro motion and also backward motion. So back and fro motion it is saying this is the oscillatory motion. The rotation of the electron along the nucleus, it is not an oscillatory motion. It is a circular motion only, but time periodic motion. In equal interval of time, the motion is repeating. So the vibration of the fans, so Turing fork, these are also oscillatory motion only, because of the fans which is having, they will move to and fro motion. So they will having this type of motion. These are also oscillatory motion only. Oscillation of the simple pendulum, oscillatory motion. Oscillator of loaded spring. So let me take, this is the loaded spring like this. If it is going downward direction, again it will come to the same position. So it will go in the to and fro motion. This is the loaded spring, also to and fro motion only. So now the oscillation of the floating body on the water. So a floating body on the water means if the body it is going downward direction, again it will come into the upward direction. It is showing the to and fro motion only. This is also oscillatory motion. Now what is our conclusion means? All oscillatory motions are periodic motions only, but all periodic motions are not oscillatory motions. Let me get the conclusion that one. So here note that what is the important note here. All oscillatory motions are periodic motions only. periodic motions, but the reverse case is not correct. That means but all periodic motions all periodic motions are not oscillatory motion. That is the very important. So what are the main condition in the oscillatory motion? The body should execute to and fro motion. That is the very important. But what are the condition in oscillatory motion? The body should repeat its motion in equal interval of time in the same path. That means the path may be not a to and fro motion. So it is in equal interval of time. The part should be repeat itself. That is the to and fro motion. From its mean position it should go front and come back to the same position, like that in the oscillatory motion will be. But periodic motion, it is not, that condition is not there. That it should complete it should pass the same path itself in equal interval of time. That is the periodic motion. That is the very important. Now we are going to the some of the small topic. What is mean by mean position or equilibrium position in the oscillatory motion? These are the small points in the oscillatory motion. Before dealing this topic, we need to know this one. So mean position or equilibrium position. So equilibrium position. So what is mean by mean position in equilibrium position in the oscillatory motion? So will you please look on this one. Let me take this is the pendulum. So the pendulum is executing from its center to and fro motion. It is going from one extreme position and it is going to the another extreme position. This point is named as the mean position. So what does that mean, sir? So a point in the path of a particle executing the oscillatory motion where the resultant force is acting on the particle is zero. That position is named as the mean position. Let me go to the what is mean by resulting force and another one. Let me complete that one. So first let me take the definition. A point in the path of particle executing oscillatory motion where the resulting force on the particle is zero is called mean position. So what does it mean? The particle is at rest. So the particle is at rest in this position means that means there is no any resulting force on that body. That's why the particle is at rest. What is the Newton law will say? The Newton law will say if the resulting force is acting, the body will comes to the motion. So what is here? The particle is at rest. This position means there is the resulting force which is acting on the object is zero. That's why the particle is in this position only. That means where the resulting force is zero, that point is named as the mean position. If we take one more example, let me take it is the calm of water without any. So this is the normal water which is having any waves on this water. Let me take this is the floated body on this water surface. That means the body is in this position only. The body is rest means what does that mean? The resulting force which is acting in this body is zero. That means how much downward force is acting, the same amount of upward force is also acting. The resulting force which is acting on the body is zero. That means if we take the oscillatory body, let me take like this, it is the waves are created. So the body is oscillating means the resultant force is not a zero. Here is the resulting force is not zero. The body is moving upward direction. Some of the force is pulled in upward direction. The body is going downward direction means some of the force is pulled in downward direction. So only the body is at this position only the body will not oscillate in any vibration. Will you please look on this one? If you go to this position, the body is trying to come this direction. That means the pulling force is acting in this direction. If you go to this direction, the body is trying to go this direction. The pulling force is acting in this direction. So that means here is the resulting force is there. This side and this side resulting force is there. But here is if you come to this position, the body will not have any motion. So if the external force is 0, resulting force is 0. So how can we see this resulting force is 0? The downward force which is acting weight of the body, the upward tension which is acting on the strain. So both are balanced. That's why the body is at a equilibrium position. That is the body is at mean position. This position is named as the mean position. So let me try this one. A point in the path of the particle in executing oscillatory motion where the resulting force the particle is 0. That point is named as the mean position. So let me take this one. Now we are trying to get the definition of the simple harmonic motion with help of this small experiment. So let me do the small experiment. We will get the simple harmonic motion definition. Very important, this one. Simple harmonic motion. Simple harmonic motion is the oscillatory motion only. So, but it is also special case. What does that means? Let me give the definition after completion of this experiment. So I am taking one of the consider one of the load, one of spring is there which is supported with one of the rigid support. So in this spring one load is attached on the bottom surface. Let me take this the load which is attached on the bottom surface. This is the rigid support. So this is the rigid support of this one. So what does it mean? It is at rest the load which is having the body. So the body does not having any oscillations because of it is an equilibrium position. Let me take the mass of the body is m. So the mass of the body m. So the mass of the spring. Let me take the mass of the spring is 0. So it is not negligible. That means we are not concentrating the mass of the spring here. So it is a negligible mass of the spring we are taking. So only we are comparing this the mass of the load which is attached to the spring. So at the equilibrium position, the load which is having at this position, if we apply certain amount of force on this one, if we pull this object certain distance, now I pull this object certain distance, the spring will elongated like this. It is elongated. The body is moved up to this position like this. So then if you release this object, what will happen? The body will tries to come back from its mean position. So this is the mean position because of the downward force which is acting, that is the weight of the body. So the tension which is generated in the string, both are balanced. This is the mean position of the object. So now from the mean position we pull down this object certain distance. Let me take the distance is from its mean position, the distance is y, because of it is the vertical axis we are taking is the x axis, it is the y axis. That's why I am taking the notation of this displacement is the y. So if you release this object by pulling down certain distance, if you release this object, the object will tries to go back to its mean position. So this object is going back to its mean position like this it is go. But what will happen? So you already know this one according to Newton's first law. So what is the Newton's second law? The body will tries to continue its original state even up to some external force will act on that body. That means it is nothing but it is inertia. The condition of inertia will tell us that. So here what will happen? So the body is in the motion. So when we release this body, the body is moving certain velocity, but the body should be come to this position. Due to inertia, the body will try to move in the same direction. It will cross this point. It will go in somewhat upward direction also. Are getting or not? Hello. Due to inertia, the body will goes to the upward direction also because of the body in the motion which is going to the upward direction. So while the body reaches up to here, the spring will be compressed. The spring will be compressed. So again, the body is not in the mean position due to the restoring force which is generated in the spring. Again, the body will push back. So again, it will tries to come down into its mean position. Again, what will happen due to inertia? The body will not be stay at a mean position. It will cross the mean position. Again, it will go to the downward direction. What will happen? It will go into the downward direction. Again, the spring will be elongated. The spring will be elongated. Again, the restoring force will be generated in the spring. Again, the body will pull back to its mean position. So the body will tries to go to the mean position. Again, what will happen? Due to the inertia, the body will cross the mean position. So again, it will go to the somewhat upward direction. Again, compress will happen. The compression, due to compression, the spring, what will happen? The body will again push back. The body will push. Again, it will cross the mean position. Like this, the oscillations will generate in the body. So, are you getting that? Hello? So what is the condition here? So the condition is at the initial state the loaded spring is at rest position at the mean position because of there is no net force which is acting on the body. How much weight is acting due to gravitational force of the body is balanced by the tension which is generated in the spring. But due to our external force, we pull down this body to somewhat downward direction with some distance of y distance we pull down. So if we release our force means the body will going back to, due to the restoring force which is generated in the spring, the body will pull down to in its mean position. But what is the main problem is the body will not directly, it won't come to the rest position, this mean position, because of inertia. So inertia means the body will continue its previous condition. What is the previous condition? Before reaching this point, the body is moving in upward direction. So that's why the body will continue, it cross the mean position. So while the body is crossing this mean position, the spring will compress. So the spring is compressed. Again, due to the spring compressed, the restoring forces will generate. When the restoring force will generate, the body will push in downward direction. So the body is pushing downward direction means again the body will come to the mean position, but it won't come to the rest at mean position. It will cross the mean position because of inertia. So because of inertia, the body will go to the somewhat downward direction. So again, the spring will elongate. Again, the restoring force will generate. The body will come. So like this, the body will continue the to and fro motion. To and fro motion means so at the mean position. So this is the mean position of the body. The body is going up. So body is going up and down. That is nothing but to and fro. Or we will name it as the back and forth. Oscillations is doing. This is nothing but a simple harmonic motion. So these, will you please look on this one, these type of oscillations are named as a simple harmonic motion. But one thing you need to know here, so the restoring force which is generating, on the body, it is directly proportional to the how much displacement is, how much elongation of the spring or how much compressed in the spring. It is directly proportional to the displacement. That means, so let me take the force. If the body is come to this position, let me take this one. So if we release our force means the body is going backward direction means who is pulling this body into backward direction? Who will pull this body to backward direction? We release the body up to here. This is the position of the body. When we release this body, the body is going like this direction means who are pulling this body? Restoring force is pulling. So the restoring force direction, see, the restoring force direction is this direction, but the displacement of the body is in this direction. Let me check this one. This is the displacement of the body like this direction, but restoring force is along this direction. They are in the opposite direction. So that means for the purpose, can we observe this one? That always can we observe this one? The restoring force. Here we will observe that one. So observe that one. The restoring force, restoring force, the restoring force F is always opposite to displacement of the body. That means, will you please look on this condition? Let me check. This is the first case. The body is here, but restoring force is acting in upward direction. The body displacement is here. Let me go to this position. Let me take this position in the body. So this is the body is here, but the restoring force, how it is acting? It is a push back. It is pushing like this one. The restoring force is direction here, but what is the displacement of the body? From mean position, the body is displaced like this direction. So it is the y. So will you please, the pushing restoring force in this direction, the displacement of the body from the mean position like this direction, here also they are in the opposite direction. That means the restoring force F is always to the opposite to the displacement of the body. This is the first condition we observed. And one more thing, you can see this one. If we pull the body, it will somewhat extend. That means we are increasing the y value. Then the pulling force, the restoring force also will be increases to pull back the body towards the mean position. That is another condition is there. And did you understand what I am saying? So what I am saying means, if we increase the displacement of the body somewhat, that means I elongated the spring somewhat more extended. So up to here I extended, that means I increase the y value. That means too, the restoring force which can be generated, it is also will be increases, because of it will pull the body towards to the mean position. That the observation is here. What is the second observation means? The second observation, the restoring force. So that means the magnitude of restoring force. The magnitude of restoring force. Magnitude of restoring force is directly proportional to the displacement of the body. So that means if more displacement is there, more restoring force will be generated. So restoring force is directly proportional to displacement of the body. So will you please, if we combine, the restoring force is denoted with the symbol of F, the displacement is denoted with the symbol of Y, then can we write in the mathematical formula? So the F is directly proportional to Y. If Y is increases, F also will increases. But one more condition is there, the restoring force is always to the opposite direction of the displacement of the body. That means they are in the opposite direction. We need to put here one negative sign. So the magnitude of F is always directly proportional to the F only, but F direction and Y direction is always opposite in the direction. It is a mathematical expression in the spring loaded system. What is the force is acting? Now I am taking this F is equal to minus K into Y. By removing the proportionality constant, I put here one the K, I put one is the K here. This is the proportionality constant. K is a proportionality constant. So in this condition we are dealing with a spring mass system. That's why we will call it as in this case we will call it as a spring constant. In this case we will call it as a spring constant. We will name it as a spring constant. So that means K is a proportionality constant. In the spring mass system, we will name it as a spring constant. Now, how can we define this spring constant? I need to define the spring constant means, let me put the K is equal to minus F by A, so minus F by Y. So that is the spring constant. So to define this one, if Y is equal to 1, then K is equal to F in magnitude. Is it correct only? If Y is equal to 1, what is mean by Y? Y is nothing but unit. Y is equal to displacement. Y is nothing but displacement. Displacement. One means unit displacement. One means unit displacement. What is mean by F1? F is nothing but force. F is equal to restoring force. Then can I define that? Restoring force. Then K can be defined like this. So the restoring force per unit displacement is called as a force spring constant or force constant, spring constant. So that means, can I define like this? The restoring force per unit displacement is called spring constant. Spring constant, or we will name it as a force constant. K is also known as a force constant. So these are the so the restoring force per unit displacement. So that means if we take the F divided by 1 means this value is equal to this only, na? What I am saying, the restoring force per unit displacement. So for unit displacement, how much restoring force is generated in the spring or in the oscillation, that value is named as a spring constant or force constant in the oscillation. That is the name of this one. So don't take this a negative sign. Negative sign is indicating that the force direction and the displacement direction is always in the opposite direction only. So let me write that one also. It can better to write here. In this part, take one point. The negative sign indicate here. Negative sign indicates force is opposite to the direction of displacement. So that means you don't bother about this one, because of some students may get the doubt here. So why should we take negative means? Please neglect this negative term here. So neglect negative term, then K is equal to F. This negative sign is indicating that the force direction and displacement direction is always in the opposite direction. So the negative sign indicates the force is opposite to the direction of the displacement. That means if the displacement is downward direction, the force direction is the opposite. If the displacement direction, force direction. So that means this is the when the body is coming downward direction. If the displacement is upward direction, it is the displacement direction. The force direction is the downward direction. It is the when the body is going to the upward direction. That is the direction of this one. This is the mean position. Like that. So then I hope no doubt about this one. The restoring force per unit displacement is named as a spring constant or force constant. Now can you tell me the units of the force constant? Units for the force constant? Tell me the units of force constant. So units for force constant is equal to K units. K units means how can you do? K is equal to F by Y. So F units is equal to Newton. Y means displacement, Newton per meter. So Newton per meter. What is the dimensional formula for this force constant? Dimensional formula for the force constant. Force, the K dimensional formula means force dimensional formula ml t power minus 2 divided by Y means the displacement. Displacement is nothing but length only. Length cancelled. That is equal to ml0 t power minus 2. This is the dimensional formula for the force constant. So if anybody confused with F means, so you go to from starting F is equal to MA only, M is equal to V by T, A is equal to V by T only, again V is equal to 1 by T I taken separate, V is equal to displacement to time only. So then you can go through like this, here M is equal to M, time S is equal to L, time into time is equal to T square. This will come to the numerator, then L to T power minus 2 will come. So F dimensional formula is equal to M L T power minus 2. These fundamental, we can come to these fundamental formula to force dimensional formula like that. So now if we move on this one, so these what we studied up to now, it is the simple harmonic motion only. So can we get the accurate definition for the simple harmonic motion? What is this? What is here? It is having simple harmonic motion. So the body is executing to and fro motion. The body is executing to and fro motion. To and fro motion. So that means back and forth motion only, but the body is moving along straight line. The body is moving along straight line. The body is moving along straight line. These are the observation what we made in the loaded spring system. So like this, the spring is moving. What I am doing? So the body is executing to and fro motion. From mean position it is going downward direction, it is going upward direction. That means it is go to and fro motion. It is moving like this. Or front and forth, back and forth motion. It is moving. So that is this condition is executing. The body is moving along straight line. Every time the body is moving in the same line, it is moving in the same line. So this condition also is executing that one. So one more condition is there. What is having? So if we take one small example, let me go to this one. So what is our observation? Before get the conclusion, let me take here. So what is our conclusion? F is equal to minus K into Y we achieve. This is the equation number 1. So from the Newton second law, what is saying? From Newton second law, what is saying? Newton second law, F is equal to MA. So I am substituting this MA here. MA is equal to minus KY we are getting. Send this M this side. So A is equal to minus K by M into Y we achieve. So minus K into M by Y we achieved. So one more time, will you please look on this one? So A is equal to A is equal to what is having? A is equal to acceleration of the body. Acceleration of the body it is having. So let me take that one, acceleration of the body. Now come to this one. Now let me check this one. So this is the spring mass system. This is a spring mass system. At mean position, the body is here. If the body is going like this direction, it is the displacement of the body. Now, what about this term? Will you please look on this one? This the negative term. Let me take this one small constant. So acceleration is acceleration. If the body is moving like this direction, the acceleration is acting in opposite direction. Are you getting or not from this equation? Are you getting or not? Hello. So are you getting it? So the acceleration is acting in opposite direction due to this negative sign. So it is acceleration direction. Now let me go this side. So the body is up here. Now body is here. So that means that this is the displacement of the body. This is the displacement direction. But how the direction of the acceleration will have it? So the body will try to downward direction. It is the acceleration direction. That means what is our conclusion from this equation? So will you please look on this one? So this direction, see in this position also acceleration is trying to come to the mean position. In this direction also acceleration is trying to get the mean position. That means the direction of the acceleration is always towards to the fixed point or mean position. Are getting or not?
Yes, sir.
So that way, the third condition I am writing here. So in the simple harmonic motion, what is here? That is the third condition. The acceleration is always directed towards to the mean position. Mean position means it may be fixed position, fixed point. It may be fixed point or mean position. So this will happen like this. So one more point is there. Will you please look on this one? Fixed point. So will you please look on this one? So let me go to this one. So if this magnitude of the acceleration is directly proportional to the displacement of the body. So will you please don't use the negative sign. Now what I am saying, A is directly proportional to the y, because of this K is a constant, M is the mass of the body. This is also one constant. So it will two constant. I am using this proportionality symbol. That means if y is increased, acceleration also will increases. So y is decreased, acceleration will also decreases. That means more displacement will produce the more acceleration. That means less displacement will produce the less acceleration. What that means? The acceleration is directly proportional to the displacement of the body from the fixed point. Is it correct or in our conclusion? Hello? Can I repeat this one? What I told you up to it? Is it needed? Let me repeat once again. So what is this equation is telling? So A is equal to minus K by M into Y it is telling. So K is the spring constant. It is a number. M is the mass. It is a number only. Number by number, one number will get. Here negative. It is a negative sign is indicating the A and Y. They are in the opposite direction. It is saying. That means can I write this equation? A is directly proportional to Y because of they are in the proportional. This is the number only, though the number will not be affect this Y. So that means A is directly proportional to Y. What does it mean in mathematics? It is a mathematical equation. What does it mean in the word? If Y is increases, then acceleration will also increases. I am not discussing the direction. So these Y will increases, A will increases, but in opposite direction. That is the main inner meaning of minus negative sign. If the Y is decreases, then A also will decreases. That means what does it mean? The acceleration which is produced in the body is directly proportional to the displacement of the body from the mean position. Is it correct or in our conclusion?
Yes, sir.
Then let me write that word also here. What are the conclusions we observed? We are writing here. So let me write the third point. The acceleration is directly proportional to the displacement of the body from where it is displacing? From mean position, from mean position or from the fixed point, from the fixed point in bracket mean position. So mean position. So then if these properties are executing any oscillation, any oscillatory motion, that body is named as the simple harmonic motion. So these position, what are the condition is having? So the body is what is the first one? So the body should be execute to and fro motion. The body should move along the straight line motion. The acceleration of the body is always directed towards to the main position of the fixed point of the motion. So the direction of the body always in the fixed position means always directed to the fixed position means in other words we will say this one. A is the direction of the acceleration is always opposite to the direction of the displacement. In other words, this is the other words we can say this one. So the acceleration of the body is directly proportional to the displacement of the body from its mean position. If these conditions are obeying by any one of the oscillatory motion, that motion is named as the simple harmonic motion, SHM. Simple harmonic motion. So what is the definition? Let me write the complete definition. Let me write the complete definition one time. Simple harmonic motion. So the definition of the simple harmonic motion means the to and fro motion of a particle along straight line such that its acceleration is always directed towards a fixed point in its path, and it is directly proportional to the displacement from that fixed point is called SHM, simple harmonic motion of the body. So what are the condition is that the body is in the to and fro motion. A particle along the straight line. The body is to and fro motion along the straight line. It is acceleration always directed towards the fixed point. So this is the first condition. Second condition in the straight line. Third condition in the fixed point. Fourth condition, it is directly proportional to the displacement of the body. Then that oscillation is named as the simple harmonic motion. 4 conditions must be executed. So let me see here. All points are written in the same one sentence. So body is executing to and fro. First condition. It is moving in the straight line. So the body is always the acceleration in the fixed point only. So the acceleration is always directly proportional to the displacement of the body from its fixed point. Then that type of motion is named as the simple harmonic motion. So will you please tell me any one of the motion which is having the simple harmonic motion? So let me go to the examples. Which one is the simple harmonic motion? Which is not a simple harmonic motion? Tell me, is there any simple harmonic motions are there? What we started here. In starting we took some examples. Any one of the simple. Let me check this. The rotation of the earth around the sun, it is a simple harmonic motion?
No, sir.
It is not in the straight line, so it is not. Let me take this one. So SHM, I am taking SHM. So let me take in the another color. SHM we are checking. So it is not a simple harmonic motion. The vibration of the string, so that means a stretched string. So is it a simple harmonic motion? So this is a simple harmonic motion. The rotation of the electron around the nucleus, is it simple harmonic motion? No, it is not. So the vibration of the quartz of the tuning fork, is it simple harmonic motion? So because of see, they are in the straight line only. So it is moving back and coming back. It is a simple harmonic motion. Oscillation of the simple pendulum, is it simple harmonic motion? You may get the confusion. Keep it aside. We will discuss separately this one. We will discuss separately. You may get the confusion. Let me keep it separately. I will come to that portion also. So oscillatory of the loading spring is a simple harmonic motion. Yes, sir. Oscillator of the floating body on the water is a simple harmonic motion. Done. This one. So these are the simple harmonic motion. Is it a simple harmonic only? Oscillator of the floating body on the water surface, it is a simple harmonic motion. But come to this one, oscillation of the pendulum, simple pendulum. But it is a simple harmonic motion only. But in the special case, then only it is a simple harmonic motion, and other case it is not a simple harmonic motion. What is the case means, if the displacement is a small, let me take this is the pendulum, it is the main position of the pendulum. If we drag the pendulum very small distance, then this is the small distance I displaced, this is the small distance I displaced, then it will move in the straight line. Otherwise, if you displace the very huge distance like this, I displaced like this, so it will move in the circular path, like this it will move in the circular path. It is not a simple harmonic motion. This is only simple harmonic motion. Hello, are you getting or not? Hello? So the simple pendulum, the motion of the motion of the simple pendulum for the small displacement is a simple harmonic motion. So the vibration of the motion of the pendulum for a long displacement, if the theta is long, let me take the theta 1. So theta 1 is very small, only simple harmonic motion, SHM will come. So theta is large, theta is very large. Then it is not a SHM. It is not a SHM. This case we are not discussing in our running topic. We will discuss only if the body is in the small displacement. Somebody they may get the doubt why the small displacement in the straight line motion means better to use like this circle. So let me take one big circle. So let me take this the big circle. Let me take this a big circle. If I make the small portion, please look on this one. If you take the small portion, it looks like a straight line only. Hello.
Yes, sir.
So that is the case I am telling here also. So that is if this is a big circle, if we take the small displacement, then it will appear like a straight line path motion. So the body is executing in the straight line path motion. Then this is a simple harmonic motion only. So if it is a big, if the displacement is big, if the angular displacement is a huge, then it is not a simple harmonic motion. We should not consider this case it is a simple harmonic motion. This is only our simple harmonic motion. Let me close here.